Imagine stumbling upon a world that's eerily similar to our own Earth, but orbiting a distant star. Could this be the breakthrough we've been dreaming of in the quest for alien life? That's the electrifying news from scientists at Penn State University and their international collaborators, who've uncovered a tantalizing new planet that's reigniting hope in our cosmic search. But here's where it gets controversial. With so many pressing issues right here on Earth, is pouring resources into space exploration the right call for humanity? Let's dive deeper and explore this exciting discovery together. The team has identified what they're calling a super-Earth, dubbed GJ251c, located a mere 20 light-years from our solar system. This planet is roughly 4 times the mass of our Earth and appears to be rocky in nature, making it a prime candidate for further investigation. We're drawn to planets like this because they represent our strongest bet for uncovering life beyond our planet, explains Suvrith Mahadevan, the Vern M. Wilhelman Professor of Astronomy at Penn State and a co-author of the study published on October 23rd in the Astronomical Journal. http://doi.org/10.38-3881/E0E20. Situated in the habitable zone, or the Goldilocks Zone as it's fondly nicknamed, GJ251c is at just the right distance from its host star for liquid water to potentially exist on its surface, assuming it boasts a suitable atmosphere. For beginners wondering what the habitable zone really means, think of it like the sweet spot around a campfire. Not too close to get burned, not too far to freeze. This zone allows temperatures where water, essential for life as we know it, could remain liquid rather than vaporizing or freezing solid. Astronomers have been chasing these watery worlds for generations, driving the creation of cutting-edge telescopes and sophisticated computer models to spot even the subtlest hints of starlight disturbances. This latest find draws from 2 decades of observations, positioning GJ251c as one of the most promising targets for life-hunting missions in the near future, according to Mahadevan. The detection relied on data from the Habitable-Zone Planet Finder, HPF, a precision near-infrared spectrograph, a device that acts like a high-tech prism to dissect starlight signals, mounted on the Hobby-Eberly telescope at Texas's McDonald Observatory. Penn State researchers spearheaded the HPF's development, crafting it specifically to hunt for Earth-like planets in the habitable zones of nearby stars. We named it the Habitable-Zone Planet Finder for a reason. We're on the lookout for planets positioned perfectly from their stars to support surface water, Mahadevan notes. This breakthrough could be one of the top contenders for spotting life's atmospheric clues in the coming 5 to 10 years. To pinpoint GJ251c, the researchers sifted through an enormous dataset collected over 20 years by global telescopes, homing in on the minute wobble of its parent star, GJ251. This wobble stems from tiny Doppler shifts in the star's light, caused by the gravitational tug of an orbiting planet. For those new to the concept, Doppler shifts are like the change in pitch you hear from a passing siren. Light waves stretch or compress due to motion, revealing a planet's presence through these subtle variations. They began by refining wobble measurements for a known inner planet, GJ251b, which orbits every 14 days. Then, blending this baseline data with fresh, ultra-precise readings from the HPF unveiled a stronger signal repeating every 54 days, pointing to a much heftier second planet. The team validated this with the NEID spectrometer, https://exoplanet of exoplanet discovery begins as Penn State's NEID spectrometer starts SIT scientific mission / another Penn State creation attached to a telescope at Arizona's Kitt Peak National Observatory. We're pushing the boundaries of technology and analytical techniques here, says Corey Beard, the paper's corresponding author, who conducted the work during his doctoral studies in astrophysics at the University of California, Irvine. https://news@uc.edu/2025/10/23/UC Irvine-astronomers discovered nearby exoplanet in habitable-zone. Future telescopes will need to image this planet directly, but what we really need is broader community backing. And this is the part most people miss. Spotting distant worlds isn't straightforward because you have to separate the planet's signal from the star's own stellar weather. This includes phenomena like star spots that can fake planetary motion, leading to false positives. To overcome this, the scientists employed advanced computational models to track how signals differ across various light wavelengths, essentially filtering out the star's noisy cauldron of activity. It's like playing a tough game where we're battling stellar noise while chasing faint signal from a bubbling, magnetic star surface, Mahadevan describes. He emphasizes that such discoveries demand top-tier equipment, intricate data crunching, worldwide collaborations, and long-term funding commitments from nations, efforts that can span decades before paying off. This find showcases the immense value of interdisciplinary research at Penn State, adds Eric Ford, a distinguished professor of astronomy and astrophysics and director of research for the Institute of Computational and Data Sciences, ICDS. Taming the stellar noise involved not only state-of-the-art tools and telescope access, but also tailoring data science approaches to this star's unique traits and instrument mix. By fusing top-notch data with modern statistical techniques, our diverse team turned raw information into a thrilling revelation, paving the way for upcoming observatories to hunt for signs of life outside our solar system. Even though current tech can't image GJ 251c directly, Mahadevan points out that forthcoming telescopes could probe its atmosphere for life-indicating chemicals. We're always looking ahead, whether training the next wave of students in groundbreaking science or engineering new gear to find potentially life-supporting worlds, he shares. This newly found exoplanet is ideally placed for scrutiny by more advanced tools. Mahadevan and his team are already gearing up for the era of 30-meter class ground-based telescopes, which will come equipped to capture images of nearby rocky planets in habitable zones. While we can't yet verify an atmosphere or life on GJ251c, it stands out as a standout prospect for upcoming studies, Mahadevan concludes. We've made a remarkable find, but there's so much more to uncover about this world. A complete roster of contributors and funding sources is detailed in the paper. http://d.org/10.3847/1538-3881/E0E20. Support for Penn State's involvement came from the U.S. National Science Foundation, NASA, and the Heising-Simons Foundation. Now, here's a thought-provoking twist. Some argue that with global challenges like climate change and poverty demanding our attention, investing billions in space to find alien life might be a luxury we can't afford. Others counter that such discoveries could unite humanity or spark technological advancements that benefit Earth. What side are you on? Do you believe the search for extraterrestrial life is worth the cost, or should we focus more on our own planet? Share your opinions in the comments. I'd love to hear your take.